they're also called gripper TBMs. And what they have is a cutting head here. This has on the front of it what's called disc cutters for rock. Disc cutters, when you think about cutting and digging, you think of a shovel or some sort of an excavator like a backhoe with a claw. These are actually discs, literally discs. They're fairly large, very well designed, and what they do is actually they put pressure on the rock as the TBM pushes against it, and they fracture the rock. They break the rock off in pieces. And you don't have big chunks, you don't have big boulders. A good TBM will cut basically flakes off about the size of your palm. And in the hard rock like you have in Tennessee and Nashville, limestone is very suitable for this kind of an approach. And what happens is this TBM, this will rotate, it'll push against the ground, and it'll cut, and the material that's got cut will come back in through here into a conveyor system. This is the conveyor back here, and it'll go and be deposited in muck cars, or it'll go to some other mechanism to get it out of the tunnel, up to the street surface, and trucked away from the site. And what happens with these gripper TBMs, you see these pads here, what happens is as the TBM, it basically you advance the TBM by big hydraulic cylinders in this back portion here. But what happens is these grippers they push against the rock, and so the machine stays, and all that advances is this front section. Then the grippers come back in, and they slide up again. They pull the cylinders back in, these hydraulic cylinders, and they kind of inchworm their way through the ground. And that's basically how it works. And the technology is very sophisticated. You can see just a scale. This is probably about a 25-foot diameter machine. You can see the people in here. It's people work and operate in the ground inside the TBM. And what happens above, you very rarely see any impact. Very low vibration, very low noise. People think, they hear it. Sometimes they're not even hearing it. It could be hearing the washing machine downstairs for all they know. It's very low impact. And once you're tunneling and once you're moving through the ground, especially in good ground, the operation is very automated, very systematic. And it'll work 24 hours a day typically. They'll usually have a maintenance shift at night, but basically the operation will continue on until they complete the work. Now, one other thing I want to just jump back on. Sometimes we have to support the ground. Even in rock, sometimes we'll have to put bolts into the rock to tie it together. And what happens is that's all done, again, from within the TBM in this back area. They're actually putting bolts or what we call initial support in the rock. And then later on, in most cases, for what's called a two-pass lining, they pour a concrete liner inside, and what you'll see when you drive through a tunnel is the concrete, but they're actually just holding back the rock. There's also a case where you can do what's called a one-pass liner. In that case, the precast segmental liners are placed in a ring as you advance the TBM, and then you don't have to pour concrete and cast in place concrete. So there's a lot of technology that went into developing these machines. These machines are very robust. If you were going to make a transit system on the street surface in something like downtown, this is in a downtown area that isn't even quite as busy and vibrant as Nashville, this is what happens when you have to put the tracks down. A lot of surface disturbance for a long time to build. This is actually Park Avenue in New York City. There's a TBM underneath that street while we took this picture. They're down about 40 feet below the grade, and they're actually boring 2 tunnels below the street. Oops, wrong button. Again, this just shows you, so I'll show you some quick jobs that are similar in some respects to Nashville in urban areas. This job was 2nd Avenue subway, but again, what we did was, and this is the picture Ian showed you before, it has, the TBM is launched from a cut and cover box, and the TBM advances through the rock. It was about very successful. The work was done. People didn't get disturbed. It was basically done completely right under a very active portion of an urban area. And again, this is when we get to a station. What happens at a station, the TBMs, even though they look really large, when you look at a station, the TBMs are relatively small. They're only typical transit, 23, 24 feet in diameter, 22 feet. This is an opening for a station cavern, something similar that may be built in Nashville. And what happens is this is where we implement the sequential method. Once we get these TBMs through, or it can be done before the TBMs come through, We open up these little slots, excavate 1, 2, 3, 4, 5, and then what happens is you open up what was 2 TBMs into a big opening, and that's where you put your station, your platform, and all the various parts of your station. This just shows you what we do with the SEM and rock. We drill and blast. We'll actually drill these out. This is a case where this is going to be the shape of the tunnel. These are all drill holes to put explosives in to blast that front face to make that opening. And again, concrete liner goes in. This shows you the liner. Cast in place liner is a movable form. The concrete's built, and basically the structure of the tunnel station is built. This just shows you again the cutting end on the TBM, and this you can see the cutters. They're like shaped like little frisbees, and that's basically the cutters in a rock tunnel. And this shows you a real good picture of the gripper. That's the gripper, and they build these, put the TBMs, drive them in to the site, basically in a truck in pieces, and they bolt them together down in the excavation. Again, this just shows you waterproofing and whatnot. You also waterproof the structures, so you have a dry, permanent structure that's protected. This is a waterproofing membrane going in, and this is the TBM tunnels that were built. And this is actually what we call a glory hole. When they get the muck in here, they pull it out of a hole, something like that, with a bucket. And we have, a lot of times, use a muck house. It's actually a contained house, so there's no dust and vibration, and the trucks go in, fill it up in the muck house, and drive away. And this just shows you another job. These are very complex configurations. This one had 4 TBMs, 2 on 2. And it went right under a very historic Grand Central Station. Hundreds of thousands of people use that station every day, and the station was operated without any interruption whatsoever. The people didn't even probably know what was going on. The train traffic in the station was probably more vibration than they ever felt from the TBMs. So it's one of these things where this is what, and these are not, again, little people. This shows you the tunnel. This is a 22, 23 foot diameter tunnel, and each one of these traces is how the cutter, that's the cutter head. That's what you see, that actually chips off all these little pieces of rock. And this is the station cavern. You can see the 4 TBM drives here. This is a large station. This is about a 65 foot wide station by about 60 or so feet high. That's a big station. You probably wouldn't go that large in Nashville. You probably don't need it that big. But this, again, shows you what the rock face looks like. And if anybody's been to the Peachtree Station in Atlanta, you can actually see some of the exposed rock in the station. That's just an architectural issue. And again, another job, again, just to give you the perspective, these jobs were all done in very urban areas. People lived, communities worked, nothing stopped. The tunnels went on and the tunnels were built. And this just, again, shows you the cutting head on a TBM tunnel. And with that, I'm going to turn it back to Ian.
Sorry. Okay, so we've given you a little bit of taste of what tunneling is, how it's done, and also showing you examples of where it's been done in other cities. Probably more difficult than what it is in Nashville. So my question is, why not tunnel? So the last guy who was talking said they didn't even imagine a tunnel could be built. Brad got us involved in this probably 4 or 5 months ago, and since then we've tried to listen to some people over time, and they would tell us like why they didn't think a tunnel was possible. So around this room, give me some reasons why a tunnel wouldn't be possible in Nashville. The 2 experienced people. Anything? Pardon?
Cost.
Cost?
Limestone.
Limestone?
The river.
River? All good reasons. Anything else? So those are 3. Some of the business owners also have been concerned that it'll affect their businesses. Like their building is going to fall into the ground. It's a legit concern. If it was underneath your house, you'd have the concern, I believe, right? So they're all legitimate concerns. So going into some specifics on that tunnel, on this tunnel. But first, do you guys have a hockey team?
No.
It gets crowds. So that's one reason why, regardless of the cost, I think this tunnel is a solution that just reduces some impacts. So as currently planned, and it is only a planning stage, but the approximate limits would be from Music City Central to South Broadway. And in between there, you'd have 2 underground stations at Music City Central and at Broadway. So limestone. So limestone is very hard rock. To me, that makes it easier. So it's easier to build a tunnel in rock than it is to build a tunnel in soil. Chicago was just part of a tunnel in Virginia where we were tunneling underneath of a body of water in very loose soils. I mean, soils where you could literally, if you would jump into them, you would sink down to your waist. So horrible, horrible soils. So those are extremely difficult. You have to support them. I mean, you dig a hole, 1 foot in the ground, it's going to fall in. So let alone in here, in Nashville, you can dig a tunnel TBM 25 foot in diameter and it'll support itself. So some things that help with tunneling here are the strength of the rock. So extremely hard rock, it's probably 5 to 10 times stronger than typical concrete. It's also pretty deep. So once it gets underground, once the tunnel is where it needs to be, there's going to be about between 40 and 80 feet of cover. So over that 40 to 80 feet of cover, all the stresses from the surface buildings will essentially arch over the tunnel. So the rock essentially supports itself and supports the buildings over top of it. So no movement of the buildings on the surface due to instability of the ground. So it actually makes it easier. Flood protection, someone else mentioned that, the river. This is underneath the level of the river, but the rock keeps most of the water out. So if parts of the rock are encountered that have water, they essentially grout them, or the liner essentially will be waterproof as well. So the water will stay out of the tunnel. In terms of flooding, the easiest way to mitigate the risk of flooding is to have the portals above the flood elevation. So you can imagine, let's say the river floods elevation plus 10. So what you try to do is have the portal at elevation plus 10.1 or higher. So therefore, no matter how high the river ever gets within reason, it won't flood the tunnel. There's also been concerns that it's going to affect how downtown looks. It's going to make it look, take away the character, etc. So I think these concerns are not really valid if you look around the country at different places. Station design is one thing that has a lot of public involvement. So if Nashville wants one of these stations to be a big architectural landmark feature that's going to be featured in magazines, on the covers, anything, that can happen. It just has to have stakeholder input. Conversely, if you want to hide the stations, make them part of the building to keep the character of downtown as it is now, that's also easily done. Just need to have stakeholder input and make it happen. The stations are designed so you really only see this tunnel in 2 places. You'll have the 2 stations and you'll have the 2 portals that are well outside. So make it what you want. Just have early stakeholder input, and tell the city and tell the decision makers what would make it good. Another concern is how it's going to tear up the streets. So Frank showed you one picture of a light rail system going in on the surface. That's a huge disruption. So tunnels underneath the ground, not a huge disruption once you're there. You also, you do have muck coming out. There's a lot of material that needs to be taken out of the tunnel, and that's also a concern if it was going to be on the streets. However, that can also be circumvented by basically taking it out one of the portals that's away from downtown. So if the downtown business owners don't want trucks on the street, you basically take it out of one of the portals. One of the projects Frank mentioned was Eastside Access in New York. Everyone's been to New York, knows Grand Central Station has hundreds of thousands of people come into it every day. It's a historical structure. The tunnel underneath that, and no one knows what's going on, was a challenge. So the way that it was done, actually, the tunneling was brought in, or the portal was in Queens. So in Queens, where real estate was much cheaper, the people didn't care as much, it was actually in the middle of a rail yard, is where they accessed Grand Central. So instead of coming into the city every day with trucks, with people, with noise, they came into the city in tunnels from Queens. So it's pretty miraculous, but all the work in New York has gone on underneath the city without anyone knowing. So the same can be done here if that's what's needed. So not a huge concern. With that, any questions on tunneling or your specific tunnel here? Yes, ma'am.
Can you talk about the rock claw, piece of equipment that actually scrapes out some of the time?
So the TBM, or?
Well, I guess they called it a rock. The last time I saw a presentation, it was called a rock claw. That it would smooth out the inside after, if there was anything left besides the TBM.
Few concerns. So the TBM essentially makes a pretty smooth hole, and you don't need to do that. What they're probably talking about is if you have blasting. If you have blasting, you can imagine that it's not a perfect circle or a perfect shape around the tunnel. So sometimes you'll have loose rock left, or some hanging rock needs to be taken down. So with that, you essentially can take it down with the claw, you can take it down with the drill, but it's just an after measure essentially to get the shape that you want and to get down any loose rock.
And if you look at this picture, and that's what I wanted to show you, this material out here is the rock after the TBM passed through. It actually looks like you put a cookie cutter through the rock and just slide right through. This is actually the rock after it's been shot out for the station. So again, the little things that are a little bit of tights, or they call them tights or overbreak issues, those things can be loosened by a mechanical excavator like you mentioned. But typically with the TBM, especially for the running sections of the tunnel, it's a smooth surface. There may be some support needed in bad rock zones, but usually the problem isn't making it bigger, it's keeping it, from getting, keeping it the same size. So it usually isn't a big issue.
Yes?
I have two questions for you. What is an example of the rate per day these progress?
So it really depends on a lot of things, how fast the contractor wants to go. But you can go up to 100 feet a day. It's pretty standard, but pretty good. But more standard is probably on the order of 30 to 40 feet a day. And a lot of it depends upon maintenance and how much muck you can actually handle. So if you just push this thing through the ground as fast as you could probably get 100 feet a day. But it needs to be maintained. It's a big machine. Unscheduled downtime is a big deal. And you can imagine all this rock needs to go somewhere. So you have this full face of rock that has to be trucked away, conveyed away. So that sometimes limits how much you can actually do is what you can put on the streets.
The average, you're talking 30, 40 feet a day average, typical.
Okay. And the second question, these examples you've shown, how close to original cost targets for the project?
You probably have numbers on them.
Actually, most of those jobs, except for maybe one of them, one of them was ahead of schedule and under budget, and one of them was right on budget on schedule. The other one, and again, a lot of these things, what happens over time, a job evolves even after it's on the street. So sometimes you hear about cost overruns. Sometimes the job started as job A, it became job B, and there were things added and changed during design. That's where you get most of your cost issues. Cost changes because of a change during design, after design, during construction, because that's where you get more money coming in. So most of these are on schedule and on budget.
Yes?
So if the government had all the money today and the planning for it, about how long do you think would it take to build that tunnel from Music City Central to Sobro?
It's a trick question in a way, but because the planning and the design process is a little bit iterative, and so you have to get to a point where the city is getting what they want to do. And you also have environmental documents and environmental agencies to please and to satisfy.
Your NEPA document. Your NEPA document has to come out first to get yourself a record of decision, so you can even start designing and really moving it forward. So depends on, some of the jobs are done fast track. Design phases 3-4 years, 5 years, depending on how evolved it is, and then the construction could be anywhere between 5 and 7 years, give or take. So you're talking 7-10 years, 10 years or so, from beginning to end. Again, through the environmental process. Environmental process ties the job up until they get the authorizations.
I have a small lead-in on that. Usually these processes aren't isolated as well. So while they're working on most of these documents on the front end, we will start, so I work for a construction firm and we worked on a tunneling project together. So we would start doing our due diligence and start getting ourselves prepped. So it's a matter of selecting and being collaborative. So even if it is a 10-year tenure that you're looking at, you might be able to scrunch it down to maybe 7, 8, at best 7, but there's ways to save time on these. And obviously one of the biggest hurdles that we see on the construction side would be funding. And that's not just that the government raised taxes and everything's good, but also if you can go different delivery routes, and that's more into being collaborative. We can accelerate these projects even more than just 7 years.
Thank you.
Yeah.
Yes, ma'am.
Okay, I'm probably gonna sound silly if I ask this. So with this little tunnel project, so no building's gonna crash down because, like you said, like people they didn't know like, that they were like underneath them and all that stuff. So like we gonna be driving.
They will
cars.
know, right? So prior to this, part of the environmental document that we're talking about here is getting all the stakeholders and business owners to buy in and accept what's
Yeah,
going
we
to
don't
go on.
sneak in there
So-
one night and build a fire. And there's a very public involvement, like Ian was saying. People know, but what I think the building falling down thing, there's a lot of ways to deal with that. First of all, in rock, like Ian said, the rock really supports itself. The people in Nashville, the buildings are the least of the problems. It's really just basically getting muck in and out of the tunnels. And that'll be done outside the limits of the downtown, where the portals are. But the issue with the buildings, what we do with all these jobs is we do building assessments up front. We look at every one of those buildings, we do a survey, make sure we know the condition of the building. Next thing we do always, even in rock tunnels, even where we don't think there's going to be an issue, we'll put an instrumentation and monitoring protection system in place for the tunnel, for the buildings. Those buildings will be monitored as this thing goes through. When we went on to Grand Central Station, we monitored that full-time, 24 hours a day, with all kinds of expensive and extensive instrumentation. So if something goes squirrely, something happens, we'll know about it, and then there's a plan to react. So buildings are protected, buildings are monitored, very low risk in rock, but even that, we always have checks and measures in there. Because it's, again, people's livelihoods, people's property, people live there, has to be protected.
Yes.
Who, and this might not be something y'all can answer, but who owns that property, that dirt, that far underground? I mean,
So essentially it's vertical
is there an
lines,
easement
so-
that has to be acquired, or?
Yes, there'll be easements. Permanent easements and temporary construction easements.
So the buildings above, or the property owners on surface level, own that?
You
I
try
mean-
to stay inside of the building
Yeah, you
limits,
stay-
right? So let's
stay
say
in
you
the
have a
public
street.
corridor.
So you are saying, okay.
Yeah,
okay.
there's no reason for this structure to go into the building lines on this
Okay.
site. And most of the time, we try very hard to keep it within the public right of way.
Sure.
If there's something that has to go, like an ancillary, there'll be ventilation facilities, because you gotta get air in and out. Those things may be off-site, but again, that's all worked with the community, and those are small
Gotcha.
little parts of it. But yeah, there's gotta be easements if there are any encroachments, but that'll be part of the process of the design and procurement.
Yes.
I have a quick
Is
question.
the,
Sorry.
Oh, no, go ahead.
is the stuff that is the limestone that you're pulling out of here, is that reusable?
Typically.
Okay.
So here, the majority of it is, it's not known to be contaminated, as
Yeah.
far as we know. So you can use that for riprap, to build roads, to put in concrete. I mean, it's got a ton of uses once you get it out of here.
Is that owned by the people who own the mineral rights?
Now, usually it goes to usually the contractor disposes of it if he can sell it, if he can reuse it. Limestone has a lot of uses, it's good aggregate, it's not bad material, and again, contamination aside, it's a lot of reuse. Actually, it's one of the real big things we try to do is sustainable design, even in that, to reuse it and be, positive reuse. We do want to put this in a landfill.
Yeah.
So, just to lead in on that, part of this is also major infrastructure projects in the U.S. have started getting this rating called Envision, which is kind of like your lead for buildings. And you can usually shoot for those rating systems, and part of that is reuse like this, just taking all the limestone and reusing it or providing it to suppliers outside. And that helps you offset some of the carbon footprint that you might have, so, yeah.
I was just curious about the length of the proposed Nashville tunnel compared to some of the others that you've done on it there. It's about the same length?
So I
or
believe
this is kind of
currently, just with the
smaller, or-
limits they have, is a little over 1.5 miles.
Uh-huh.
And I mean, there are tunnels in
Yeah.
all different shapes, sizes, lengths.
One of the ones we showed you was,
Yeah.
yeah, one of the ones we showed you, 3 stations, about 2 miles of tunnel, same kind of dimensions, same kind of limit. So it's very reasonable and common zone. Sometimes they're much longer. Shorter, you probably wouldn't go much to a TBM. sometimes they'll do a different technology if it's a
I'm just
shorter
wondering
tunnel.
down the road in the future if it's feasible for it to be expanded. You know, this is just the first little part.
You could come in and expand it all you want. No, this actually, the subway, just example, subway systems in LA, we're working on green line, purple line, purple line and, it might be green, gold line, gold. And those are extensions of existing subway systems. In New York, Second Avenue subway, the original subway was built in the 1905, we're still adding on to it. In DC, we're adding on, Atlanta, we adding on, everywhere. So they're very adaptable. As a community and basically the population centers shift, you can shift the limits of the tunnel.
I just think people might understand it a bit more. I mean, I think when people see it, they just see that one little tunnel, but if they think of it as part of a future network, it would be, people may, support it.
It's a starting point, right?
Yeah,
So-
starting point, exactly.
And when you work in such, these urban areas, and some are more urban than others, it's very hard to work on the surface these days. You got utilities. If you look at underneath the street, you don't even realize how much stuff is under there. And to open up the street, we open them up. It works. It happens. Cut and cover is done. But again, it's a technology that we don't want to disturb people's lives, and they don't want their lives disturbed. And you can still do what you need to do without. And that's really, I think, the goal in most of these jobs in urban areas.
Yeah, I think it'd be great.
Yes, sir. Sorry.
So what's you said talking about lack of disturbance there, what's the cost on something like that? If you had a million or 1.5 miles, maybe rough?
Again, I don't know the numbers. It varies. Again, what drives a lot of it is where you are in the U.S. New York City is not Nashville, and LA is not Nashville. The cost of doing business in a lot of these places is significantly different. I don't know what it would run down here. We haven't run any numbers on it, but it varies. Again, it would be cheaper here relatively. It would be cheaper here to build this tunnel here. It would be cheaper than building in New York, in LA, in Boston, in DC, and probably some of these other places where there's another component of everything we do.
So you mentioned the ground is not known to be contaminated. What do we know about the limestone other than it's pretty strong?
That's pretty much what we know. That's the conclusion is that. But there are some fractures and faults.
Yeah, seem like you got it.
There are fractures and faults. Downtown has been developed. So every time that a building is built, these high rises, they do borings in the ground. So we've looked at some of the information that's been done for the Batman building, I believe. I think that's what you guys call it. And some of the other high rises. And the conclusion that we've drawn, and we've also looked at the excavations that they're doing right now. And you can see that the rock is good. We know it's limestone. We know the strength of it. We know about how fractured and how weathered it is. And as time goes on, this project advances, an additional investigation will be done to know everything you need to know about it for design and construction.
Yeah, you do have karst features in some of the limestone, which are solution cavities, but they're not predominant in the downtown area. Some of the other areas are worse. But there would be, like Ian said, there's going to be an extensive, full-blown geotech investigation before you go into the ground, so you can answer all the questions. I was kidding. We don't know as much as we need to know to build this thing now, but that would be done as part of the process and has to be done, because the risk of not knowing is a cost risk that no one wants to carry, contractor or owner or designer. So we make sure we try to get as much information to the guys who have to build this and design this as we can.
Great.
Yeah.
This area has a lot of natural caves. What happens when you start, drilling and there's a cave?
That's a karst. That's a solution cavity. The caves are basically, what we do is through the investigation that we do up front, we'll do geophysical, geotechnical borings. We'll do extensive programs that looks for these kind of features in this area. If there are karst features, and we built the Cumberland Gap Tunnel between Tennessee and Kentucky, and we found caves in there. You're right. A lot of those are filled in. You backfill them. As long as you know about them, you deal with them. And again, when the investigation comes, we'll find hopefully the bigger ones. If not, what we do is it's not like we just turn that machine on and it goes and we catch it on the other end. It sounded silly, but it's true. What we do is the contractor will do pre-boring in front of him. He'll actually, as he's boring his tunnel, will drill ahead of himself, and he'll actually look for cavities, look for water areas. So that's how we, again, before we get a big TBM and everybody's sitting there saying whoops, we try to find them before we find the whoops.
Yeah, you can't go whoops on a huge project.
Whoops is not a good place.
Go whoops.
Yes.
Kind of a related question, and partially just because 50 feet under the earth sounds like this whole new world to me. So just a fun question, what's like the craziest thing that you've ever found as you're doing these tunnels? Or have you not really found anything?
They're like fossils, like are you digging, you're like, you need an archaeologist quick, like.
So in some projects, we did a tunnel project in Istanbul, Turkey, and they came across fossils as they were digging. And it actually, if you find something like that, that's actually time that stops the project.
Yeah.
Because this has historical importance, so they need to do an investigation and uncover all the architectural or all the historical features and try to figure out, piece history together. So if that's encountered, the project stops to investigate what it actually is.
The cultural resource issues are always there. That's part of the investigation up front. You're going to look for potential cultural resources, and that'll be part. Hopefully you've identified them up front. We had a job once where we were digging a tunnel, and every morning, contractor, they do prep, and we'd have the guys out there, and there'd be a guy carrying a pail, and he'd take this pail, and he'd go into the trailer with this pail. And so we're saying, what the heck is in this pail? So one morning, we grabbed the guy and said, what's in the pail? It was full of bones. And we said, oh my gosh, what have we found? So we called the cultural resource guys in. Cultural resource guys came in because we thought maybe it was a cemetery. We didn't know. We were in an urban area, could have been, something, and we were in soft ground. We weren't even in rock. What happened was, it was actually, they did the archaeologists came out and they looked at it. It was actually, it was an old slaughterhouse for animals. So they just buried the bones back in the 1800s or whatever. So it wasn't anything bad. But again, you never know what you find, and this was one obviously we didn't know about, but it was nothing bad.
The limestone here is like 450 million years old plus, right? So
Some
that's
fossils.
before there were vertebrates
fossils
on Earth, so there's not going to be that much cultural heritage.
Yeah, not in the limestone. But you have really cool fossils. You get some really nice fossils in these deposits that, some of the cool things we find, you find these chunks with some different old animals.
Our hockey team does that.
Yeah.
Saber tooth.
If you run across fossils, do you have to call in?
Nah, fossils are fossils. They're just something you put on your shelf and give it to your kids.
Any other questions?